Hi everyone, on my YouTube channel, you're welcome once again to learn chemistry with Obum. I'm here to teach you today on biogas, and my lesson today is what can we do with biogas. As you already know, I'm Obum Neke Inhanachonwachko, an MSc graduate from the University of Aberdeen, Scotland. Our aims and objective of this class is to define what biogas is, know the composition of biogas, how can we produce biogas, and the various uses of biogas. Now, the first question is, what is biogas? So many people have a different definition of biogas. Some call it biological gas, some call it different name in different countries. But what actually is this biogas? Now, biogas is a mixture of methane and carbon dioxide with small quantities of other gases that are produced by the anaerobic digestion of organic matter, for instance, agricultural waste, food scraps, and sewage sludge in an oxygen-free environment. What we actually mean is, it is a gas that is produced in an environment that there is no oxygen in it, and majorly from the decomposition of agricultural waste, such as the sewage sludge or the waste which we usually dispose in the sockaway pit. It is a renewable source of energy. It is versatile and sustainable, and it benefits both the environment and the society. There is no harm at all. So what are the keywords we get from this definition? Renewable. It is capable of being renewed or replaced, or you can say it is naturally occurring. Anaerobic, without oxygen. Versatile, widely used. And sustainable, it can be maintained to a certain level. Now, what are the composition of biogas? Like I said before, it is usually composed of methane, carbon dioxide, and some other gases in little or negligible quantities. And here is a table below showing the various feedstock we use. What are feedstock? Feedstock is the main compound or the main composition we will be using to generate the biogas. For example, the agricultural waste, the sewage sludge, they are all feedstocks. So now this is a table showing you the various feedstocks and the various composition of the gases they generate. For example, the sewage sludge, as you can see, if you use it as your feedstock, you'll be having methane up to 65 to 75%. That will be the amount of gas the methane you'll be producing will give us. Unlike if we use landfill, that gives you only 45% of methane. So what does this entail? It shows that the feedstock you use will determine the quantity of methane you produce. Also, as you can see from the sewage sludge, the carbon dioxide is up to 20 to 35%. Unlike in the landfill that gives you about 35 to 55% of carbon dioxide. Then other gases such as the hydrogen sulfide, ammonia, carbon monoxide, nitrogen, oxygen, and other traces are in negligible quantities. Now, let's go over to how we can produce biogas. The end use of the biogas dictates the depuration targets. That means how pure our biogas should be. Now, if you look at this sketch from the organic matter all down way to both the agricultural waste, like you can see the crops, the cow dung, and some woods, they are all our feedstocks. All these are our feedstocks. Now, if you put the feedstock into the anaerobic digestion, which is this is the anaerobic digestion. After a while, it produces our biogas, which we can use directly for cooking. For example, here in Nigeria, we use it directly for cooking, and the waste is called the digestate. Yes, and this waste digestate also serves as a very wonderful manure or fertilizer because it's more of ammonia and is very good for your crops. Now, from the digested, from the anaerobic digestion, we can also let the biogas out to upgrade it. That means to remove every form of other gases in it so that we can obtain our pure methane. And that's exactly what we try to do by upgrading it. When you try to upgrade, you are now converting the biogas to pure methane. So you are no longer producing biogas, you are producing biomethane, which is what we are trying to do by upgrading. And what do we mean by upgrading? I will explain it in the next slide. But before then, what do we mean by gasification of solid biomass? It simply means the heating of biomass up to a temperature of 800 degrees and high pressure in a very low oxygen. Remember, we don't actually need the oxygen to aid us in the anaerobic digestion. So when we heat the biomass up to 800 degrees in the absence of oxygen, we produce what we call the syngas. Syngas is a mixture of carbon monoxide and hydrogen. As you can see from the equation here, if we have our methane and carbon 4 oxide reacting, it gives us this syngas, which is carbon monoxide and hydrogen. Then what is methanation? Methanation simply means a process whereby the carbon monoxide and hydrogen is mixed together to produce the pure methane and water, and that's exactly what is happening in the upgrading here. That's exactly what's happening here in the upgrading. We have here our methane, our biogas, which is methane and carbon 4 oxide, reacting to produce us syngas, which is carbon monoxide and hydrogen, and the carbon monoxide and hydrogen mixing together to give us pure methane and water, which is the end product we have here as the biomethane, and it can now be supplied to gas network. For those in the UK, it can be supplied to the national grid, the gas national grid, or it can be used also for electricity. So this is a simple sketch of how we produce a biogas, and you can see the last equation here is the syngas reacting to produce the methane and water. Now, upgrading of biogas. Upgrading simply means a process whereby we remove the carbon dioxide, as stated earlier, and other negligible gases from the biogas to produce pure methane. It involves several processes. We can use the water scrubbing or membrane separation. Water scrubbing simply means it involves passing through the biogas, which is methane and carbon dioxide in water at low temperature and high pressure. If you pass the methane and carbon dioxide in water at low temperature and high pressure, the carbon dioxide separates from the methane, forming carbonic acid. The carbon dioxide forms carbonic acid and settles, whereas the biomethane, which is the pure methane, goes up and we obtain our pure methane, and it's simply called water scrubbing. Another way to separate the gases, that's we are now talking of separation of gases, involves membrane separation. And membrane separation is based on separating different gases based on their ability to permeate or enter a membrane differently. It simply means that every gas has a different permeability for a particular membrane. So methane and carbon dioxide, if you pass them through a particular membrane, they will move differently. Methane will pass depending on the membrane we use, leaving behind carbon dioxide, and that's another way we use to separate the gases. Now, finally, what are the various uses of biogas? One, in the UK, there are over 109 biogas plants. In Nigeria, here in Imo State, we also have a gas plant, although it's not actually a biogas. The uh, one in Ohaji is a natural gas plant, but not actually a biogas. So what we mean in essence is that biogas can be used in power generation, can be used as a combined heat and power, but excuse me, biogas can be used to produce heat. It can be used to feed the natural gas grid. It can be used for cooking. There are so many uses for it. You can use it to power vehicles. It can act as fuel for vehicles. Biomethane can be compressed and used as fuel for vehicles. It's also a source of fuel for our solid oxide fuel cells. It helps to produce the methane and the carbon monoxide and hydrogen needed for the anodes of the solid oxide fuel cells. These are various uses of biogas. Also, it helps in hydrogen production. Hydrogen production by biogas reforming. Hydrogen can be produced by a dry reforming process, like I said earlier on before. When you combine methane and carbon dioxide, which is our biogas, we produce the syngas, and in this syngas, you can also use it to produce in this syngas. In this dry reform process, other reactions also occur, and these include the steam methane reforming and water gas shift reaction as shown below. The methane and water react to produce our syngas, which is this. Remember, methane and water is produced when we combine carbon monoxide and hydrogen. It gives us our pure methane and water. And now our pure methane and water also, through the steam methane reforming, can be used to get our carbon monoxide and hydrogen. And if you watch here, we are producing a very large amount of hydrogen here, up to 3 moles. So this process of using biogas to produce hydrogen is also a very important process in chemistry. Likewise, also the steam methane reform reduces the production of carbon on the catalyst, and the water gas shift helps to produce large amount of hydrogen, as you can see here. Finally, carbon dioxide can be stored or removed by various techniques as stated earlier, like the water scrubbing or the membrane separation. In summary, what have you learned today? You already know that the potential of biogas is vast and diverse, from electricity generation to heating, transportation, fuel, industrial applications, and waste management. Biogas offers numerous sustainable solutions, And by harnessing the power of biogas, we can reduce greenhouse emissions, promote renewable energy sources, and also, more importantly, it is sustainable and very, very safe. So, thank you and have a lovely day. And thanks. And subscribe to my channel for more lectures, simple lectures in chemistry. Thank you.